Hello everyone, welcome back. Let's talk about another easy problem on Leetcode today. Check if array is sorted and rotated. Leetcode 1752. In this problem, we are given an array nums and we should return true if the array was originally sorted in non-decreasing order, then rotated some number of positions including 0. Otherwise, we should return false. There may be duplicates in the original array. So what they mean by non-decreasing order is that each element in the array is either greater than or equal to the element before. That is, it never decreases. So basically, it is the array in the ascending order, but because it can contain duplicates, we say that it never decreases. Then in example 1, for the given array, we will return true because we can have this sorted array, rotate it k equal to 3 times. So basically, we rotate all of these elements to the right. So now 5 comes before 1, then 4 comes before 5, and then 3 comes before 4. So the array becomes 3, 4, 5, 1, 2. And we can see that the original array was sorted. So because of this, we will return true in this case. Then in example 2, for the given array, we can't have any sorted array that can be rotated to produce this nums array. Suppose a sorted array was 1, 2, 3, 4. Then we can see that this part is sorted, but this part cannot be fixed. So because of this, we will return false in this case. Now in terms of solution, one of the naive approach can be that for each position in the array, we rotate the array towards left. Why? Because in a way, we are undoing the rotation to the right given in the original nums array. And then we validate if array is sorted in any of the rotations. If it is, the array was rotated and sorted, and we will return true. Otherwise, we will return false. For example, for this given nums array, we try to rotate the array starting from 0 rotations to n-1, that is 4 rotations. So if we do 0 rotations, the array says 3, 4, 5, 1, 2, and the array is not sorted. Then we rotate the array to the left by 1 position. So our array becomes 4, 5, 1, 2, 3, and it is yet not sorted. Then we perform 2 rotations. Then we will get the array as 5, 1, 2, 3, 4, which is still not sorted. So now we perform 3 rotations and we will get 1, 2, 3, 4, 5, and this time the array is actually sorted. So we will return true in this case. So if we find one rotation towards left where the array is actually sorted, then we will return true. But if after performing n-1 rotations, we couldn't find any sorted array, then we will return false. Now in terms of time complexity, it will be O of n square because we generate a new array for each rotation, which takes O of n time. And then we check if the array is sorted or not. That again takes O of n time. And we are doing it for n rotations. So because of this, the overall time complexity is O of n square. And in terms of space complexity, it will be O of n for storing the rotated arrays. And given this problem is easy, this solution may be accepted as well. But now the question is, can we do better? And the answer is yes. For that, let's visualize this array. So if you see this array, the numbers go up like mountain, and then suddenly there is a valley in the middle, like a blip or transition, and then it goes up again. So can we find some kind of a pattern looking at these transition points? Let's take one more example. Let's take the array as 1, 2, 3, 4, 5, and here we won't see a valley, and the elements just go up and up. So if we see 0 or 1 blips or transitions from the start till the end, then the array is rotated and sorted. But is this condition sufficient? The answer is no, because we don't check if the last and first elements are in the increasing order in case of a rotation. For example, take the array 1, 3, 5, 1, 2. In this array also we see the elements going up, then there is a blip, and then the elements go up again. But the array cannot be rotated and sorted because the last element 2 is more than first element in the array. But if this array was a rotation of some sorted array, then the first element in it should have been more than the last element as a continuation of the sorted array. Also, in this array there are 2 duplicate ones which should have been together, but they have 2 in between. So, to correctly count the transitions, we should check the last and first elements as well, because as the array is rotated, these 2 elements are connected as well. So here for example, because this array was a rotation of the sorted array, the last element is less than the first element in the array. So now using this information, let's check if the array is rotated and sorted. So here we can see that the elements go up, then there was a blip, and then the elements started going up again. And the last element here is less than the first element here. So that means there was no blip between the last element and the first element. So in a way it was like a continuation. So if we concatenate or double this array, it will again start going up. So the total number of blips or transitions we saw was equal to 1. So that means this array was sorted. Then let's take more examples. Let's take array as 1, 2, 3, 4, 5. And here the elements go up continuously. And then we compare the last element with the first element. And this time there is a blip because the first element is less than the last element. So number of transitions again become 1. Let's take one more example where all the elements are equal. So in this case, we see no transition, that is 0 transitions. Let's cover one negative example as well. Suppose the array was 2, 1, 3, 4, 5. So here we see that the elements go down. So there was a blip and then they go up again. And then we compare the last element with the first element. And again there was a blip because the first element was less than the last element. So because of this time we see 2 transition points. And that's why this array is not a rotated sorted array. So then our approach can be that we traverse through the whole array to count the number of points of transitions where the element is greater than the succeeding element or the succeeding element is less than the preceding element. And we also do the comparison of the last element with the first element to check for the continuation as they are connected due to rotation. And if number of such transitions points is less than equal to 1, then the array was rotated and sorted. Otherwise, we will return false. And one way to compare the first and last element is like we are doing with a separate if condition. But another way can be that we can incorporate it inside the for loop itself with the help of the modulo operator. So if we do nums I plus 1 modulo n, for the last element, we will get the index as n modulo n, which is equal to 0, and that handles a circular connection. So this way we can check if there is a blip between the last element and the first element. And if there is, then we will increment the number of transitions. Now let's jump into the code part. First let's initialize n as length of the input array. Let's also initialize the transition counter, trans, to count the number of transitions or blips in the array. Now we will iterate through each element in the array to check for the transitions. For each element, we check if it is greater than the next element. And we can calculate the next element's position by performing the modulo operation between I plus 1 and n. This handles a circular connection so that we can compare the last element with the first element as well. So if the current element is greater than the succeeding element, that means there is a blip, so we will increment the number of transitions by 1. And if at any point number of transitions is more than 1, then we will return false. Otherwise, if we are done with all the elements in the array and number of transitions were less than equal to 1, we will return true. Now let's submit this code. Awesome. Now in terms of time complexity, it will be O of n because we are going through each element only once. And in terms of space complexity, it will be O of 1 because we are using few variables here and there. And again the question is, can we do better? And the answer is no. But we can definitely solve it using other techniques like doubling the array and finding the sorted array of size n using the sliding window technique. We can double the array either by using the extra space or by using the magic of the modulo operator. However, I feel the video is now on the longer side. But if you are interested, I have covered these solutions in details in a post linked in the description below. If you would like a dedicated video for these techniques, please let me know in the comments. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.